Check, mic check. Good afternoon, everybody. Welcome into another live stream. Red Bull, welcome into the chat. You're the first one in today. Anyone that is new here, welcome in. My name is Dr. Andrew Sanchez, PhD in Chemical Engineering. We are going to get started for a brand new live stream today. Guys, anyone that is new here, feel free to comment the word new. We are going to go ahead and do some topics today for organic chemistry, general chemistry, mathematics, or physics. You can comment down your questions down below. Okay, and if you have any questions, you can just drop them up on my website. Guys, we're gonna do a question here. I'm gonna do 30 minutes on the clock today. Custom poll, what topic should we do today? Actually, I'll do 40 minutes on the clock. And boom, first question is up on the board. All right. Young Cook, welcome in, good to see you. All right, so today is October 14th, 2025, and we're going to do another live stream. I'm going to wait a few minutes for people to chime in, and we're going to figure out what we're going to do. I need help with Gen Chem problems. Twin, what problems are you working on this time, my friend? I've been testing 2 days. I'm cooked. I got you. What topic are you on? Okay. Guys, that's the first question of today. What topic should we cover today? But I'm going to go ahead and bring up the schedule. This is what I plan on working on today. I think we're going to do Gen Chem. Okay, I think we're going to do Gen Chem. Today is Tuesday. Let's change this to a Tuesday. I kind of like this. I think we're going to do Gen Chem for the first hour every day. Second hour is whatever wins the vote. And then the last few minutes we'll leave for Q&A. I may or may not have time for Q&A today, friends. So if you do need help, make sure you DM me for your exact questions, exact practice problems. Guys, welcome into the chat. My name is Dr. Andrew Sanchez, PhD in Chemical Engineering. If you're new here, welcome in. Comment the word new. And if you've been here before, comment the log emoji because you know we're about to log in. Si soy mexicano. It states, write Lewis dot symbols for atoms and ions of main group elements 1 to 2 and 13 and 18. Twin, make sure you check out my YouTube video because I have that exact video going over that exact problem up on my YouTube channel. Let me bring that up. Okay, so let me bring that up, Twin, because we're going to go over that today. So don't even worry. Like I said, we're going to do AP Chem and College Chem for the first hour. Okay, because IDK of Lewis dot and structure are the same thing. They are the same thing, Twin. Okay, they are the same thing. Okay, make sure you watch my video, Twin. Let me pull this up on my profile. Let me pull this up here. Okay, so go to my YouTube channel. Just look up my name. Let's hide this for a sec. So I'm going to record this. So make sure you stick around because I'm going to record this and post this. So yesterday's live stream was right here. So this was yesterday's live stream. And then I want you to watch this video for valence electrons and Lewis structures. Rest, what's your test on? The plan today is going to be as follows. It's going to be, I'll bring that up here. Okay. So, Young Cook, I'm going to do, make sure you watch the valence electrons video here. All right. So, guys, here's going to be the plan today. As usual, we're going to do vote. I think I like this structure. I think I'm going to do Gen Chem for the first hour because I know Gen Chem can be really hard. And then I meant to bring this up here. and then hide this. So this is the plan for today. We're going to do Gen Chem for 30 minutes to an hour. And then 7 p.m. for whatever is the winner. So we got 40 minutes on the clock. Make sure you vote for whatever topic you want to do. Okay? And I'm going to wait 1 more minute before we go over your questions. So Young Cook, you're going to be up first because you're asking about Lewis dot structures. So make sure you tell me your exact question. Guys, we're going to start with Gen Chem in 1 minute. So make sure you tell me your exact questions. And then whatever is the winner will be the winner here. Okay, in 1 hour. So let's hide this. And let me bring up my website here. All right, guys, we're going to get started in one more minute. But before we get started, I think I'm getting used to how to do these live streams, guys. I've been doing this for a year, and I think I'm finally getting used to the live streams. There we go. Welcome, everybody. Welcome into another live stream. My name is Dr. Andrew Sanchez, PhD in Chemical Engineering. If you're new here, comment the word new so I know that you're new. And if you've been here before, comment the lock emoji because you know we're about to lock in. My background is in chemical engineering, and I got you. If you're taking mathematics, chemistry, or physics, I got you. You can ask in any questions down in the chat below. I go live on TikTok every single week, Monday through Thursday at 6 o'clock PST, 9 o'clock EST. Guys, if you need tutoring or if you're feeling cooked for midterms, finals, exams, things like that, I got you on various STEM subjects ranging from chemistry, AP Chem, Gen Chem, or organic chemistry, physics, calculus, and engineering. You can book a free consultation call at the link in my bio. Go to engineeringminds.co. Click on the link that says book tutoring for your first free session. You can also join the Discord, which is totally free. So click on this link that says join Discord, which is also totally free. Here's where you can ask your questions. So click on this link that says TikTok Q&A and then explore resources here. Everything you need for STEM and more is up on the link in bio, engineeringminds.co. You can also shoot me an Instagram DM for your inquiries. And great, guys. So let's get started. So here's going to be the tentative plan for today. So make sure you vote in the poll, and we're going to get started with Gen Chem for today. So let's get started with Gen Chem. And let me bring this up here. So Young Cook, you're up first, my friend. So let's go ahead and do a review of what you're saying here. Let's go ahead and do a review of the valence electrons in the Lewis structures here. So Young Cook, there's no exact question, but I know I have a blueprint that says I need to know that. Okay, what's on the blueprint? What's on the blueprint? What's on the blueprint? Let's start there. Okay, so let's do a quick review. Let's do a quick review of what's on the periodic table. And let me go back to your exact question. It says, I just got cooked on my FRQ because I couldn't explain my answer well enough. Oh no, that's for math. I sent a list on the Discord. All right, got you, Shaz. Oh, I think I missed your question. I'll double check that. Okay, so it says write Lewis dot symbols for atoms of ions of main group elements 1 through 2 and 13 and 18. All right. So remember, if you were here yesterday, which if you missed it yesterday, you can watch the live stream for yesterday, but let's go over that. So main group ions from 1 and 2 and 13 through 18. So that's exactly what we went over yesterday. So I really, really would love you to go through yesterday's live stream, which I posted on my YouTube channel, and also my YouTube video that I posted the other day. All right, so let's start with topic number 1 here. So column number 1. So I'm going to put a box around column number 1, and then I'm going to start with this one that says H. So H is going to be in column number 1. So everything that is in column number 1 has 1 valence electron. Okay, so for example, H here is going to be 1 valence electron. Okay, lithium also in column number 1. How many valence electrons? Is only going to have 1. Okay, sodium, guess what? It's in column number 1, so it's going to be 1 valence electron. Okay. Make sure you vote for the next topic. Okay. And then great. So let's keep doing that. Okay. So how much for potassium? So potassium, okay, 1 valence electron. So all of these are going to have 1 valence electron. Literally just learned this in chem today. That's crazy. Right? So let's see if this is making sense. Is this making sense? So I'm going to do beryllium. It's going to be in the second column. So now I'm going to do a box around the beryllium column. I'm going to do a box around beryllium. It's going to be Be1 and 2. So that's going to be our valence electrons on beryllium here. Okay? Magnesium 1 and 2. Okay, let's keep it going. So I'm going to go all the way to the right hand side. So any questions on the left hand side? So we basically did all the elements from the left hand side. This is the group 1 elements and the group 2 elements. Let me know if you have any questions about that so far. Okay, so I'm going to keep it going. I'm going to go to the right-hand side. Okay, let me zoom out in case people have questions here. And let me zoom out in case people have questions. So I have hydrogen, lithium, sodium, and potassium all have 1 valence electron. Beryllium and magnesium have 2. If I want to do calcium as well, I can do calcium. Calcium also is going to have 2. So 1 and 2. All right. Great. So now I'm going to go to the right-hand side, guys. I'm going to go to the right-hand side, and then I'm going to basically box the entire 18th column. Now, helium is my exception here. So helium is going to be He, and it's going to be our 2 elements, our 2 valence electrons rather, just like that. So we're going to have 2 valence electrons on helium, just like that, and then I'm going to do a neon. Okay, so this is a complete octet. So now for all of these, I'm going to put an 8 on the number top here. So I'm going to put an 8 up on top here to indicate that all of them except for helium, because that was an exception, I'm going to have 8. Okay, and so the reason I got 8 is because we have 18 minus 10 because we're in the 18th row, and then neon is our 10th element here. So neon is going to have 8 valence electrons. The way I'm going to do this, I'm going to go 1, 2, 3, 4. So notice that I went top, down, side to side. Okay, top, down, side to side. So that's 1, 2, 3, 4. And then I'm going to add 4 more just like that. Top, down, side to side. Okay, so that's going to be neon. It's going to be those 2 here. All right, and then what I'm going to do next is after that, I'm going to basically do that again for argon. And I'm going to repeat that process. Top, down, side to side, and then top, down, side to side. So again, anything that lives over here is going to have 8 valence electrons. Cruise T, thank you for the follow. Thank you for the love. We're going over AP Chem, Gen Chem right now. Make sure you vote down in the chat, guys, if you want a different topic. You can vote up on the top left-hand side of the screen. Okay, let me pull that up real quick. Let me pull that up one more time. What topic should we cover today? Just like that. Okay. Great, so that's going to be our next 3, argon, krypton. So I'm going to keep doing this for krypton. It's going to be 1, 2, 3, 4, 5, 6, 7, 8 for krypton as well. All right, and then that's going to be our next one as well. It's G low-key hybridization. All right, next topic will be hybridization, guys. Let's keep this going, and then we're going to do that next poll here. Next topic will be hybridization, but we're going to do Gen Chem for 1 full hour. Okay, perfect. So then what we're going to do here, guys, is now I have an 8 right over here, and then I'm going to go 7, 6, 5, 4, 3. Okay, guys, we're going over Lewis dot structures in Gen Chem and AP Chem. If you have any questions, feel free to drop them down below. And so I basically indicated that my 18th column here is going to have 8 valence electrons because that is called the octet rule. Now, these elements over here are going to be my halogens. Okay, these elements over here are going to be my halogens. And then I'm going to basically say these are going to have 7 valence electrons. So, for example, fluorine is going to have 7. 1, 2, 3, 4, 5, 6, 7 valence electrons for fluorine. Chlorine also lives right over here. So, chlorine is also going to have 1, 2, 3, 4, 5, 6, 7. Guys, so if bromine also lives on this column here, guys, everyone comment down below how many valence electrons is bromine going to have. So if fluorine had 7 and chlorine had 7, guys, not a trick question. How many valence electrons is bromine going to have? Comment down below. Okay, very good. Very good. So you're getting it, right? So you're getting it, Young Cook. So we're going to have 7. So let's keep that process going. So 1, 2, 3, 4, 5, 6, 7. Almost done here. So almost done. Now, what about iodine? Jeremiah, it's not going to be 5. Good guess, though. It's not going to be 5. It's going to be 7 because they're all going to live in that 17th column here. So all of these are going to have 7. So same for iodine. Okay? So is that making sense, guys? Good job, Jeff. Okay, good job. Guys, is that making sense? We're basically going over Gen Chem, AP Chem, so whatever questions you guys have, let me know down below. So that is column number 8. So again, column number 8 is our complete octet here, guys. Okay, now column number 6 here is going to be 6 valence electrons. So we're going to repeat that process, but only for these 2. Only for these 2, okay? Selenium, tellurium, yes, we do need those as well, but I'm just going to ignore those. Okay, same for 5 for nitrogen and phosphorus. carbon and silicon as well, germanium, and also boron and aluminum. Okay, and so let's go ahead and repeat that process, guys. I posted this exact process on my YouTube channel. This brings me nightmares. I'm sorry, Heidi. Oh, root mean square, that's going to be in your gas velocity calculations. You guys want to talk about that? Root mean square is velocity and speed of gas particles. Okay, does AT have 7 electrons too? That's a really great question. I stopped here because I know these are the halogens. I really don't know if AT has 7. Astatine, I don't know if it also has 7. I think it does, but once we get below iodine, it gets funky here. So, and you don't need to worry about these because these are going to be radioactive. So for example, polonium, so it's going to get funky. So don't worry about anything below iodine. Great, so now we're on oxygen. Great question though. Oxygen. All right, guys, so how many valence electrons is oxygen going to have? Everyone comment down below what number, how many valence electrons is oxygen going to have? So how many valence electrons is oxygen going to have? Grace, I can absolutely do conversions. We're going to do a quick poll after this. All right, good job. Good job. 6. Okay. Is linear algebra used in chem or calculus? Not really. Not really. Linear algebra is not used in chem. Good job. Everyone that said 6, good job. Okay, good job. So it's going to be 6 because it's going to be in this column. All right. Young Cook, Vals, Jaff, H all said 6. Okay, so this is going to be 6. Sulfur is also going to have 6. Next question, guys. How many is nitrogen going to have? How many valence electrons is nitrogen going to have? Okay, how many valence electrons is nitrogen going to have? Comment down a number down below. Okay, comment down your number below for nitrogen here. Okay, so I'm going to look at nitrogen. Good job. Val says 5. So nitrogen is going to be 5. So I'm going to do my nitrogen. Whoops. Okay, I'm going to do nitrogen. Here is 5. That's true. Linear algebra is used in PChem. That's true. That's true. I forgot that linear algebra is used in PChem. Okay, good job. So now phosphorus also going to have 5. All right. Next question, guys. Ready? Next question. So how many valence electrons is carbon going to have? Oh, you guys can't see that. Hold on. Oh, you guys can't see that. So how many valence electrons is carbon going to have? How many valence electrons is carbon going to have? Comment down a number for valence electrons for carbon. Okay. So carbon. Good job, Charles. Good job, Young Cook. See, you're getting it, bro. Now you're getting it, right? So now you guys are cooking. So carbon is going to have 4. I think you guys are getting the point. Same for silicon. Also is going to have 4. And then boron is also going to have 3. So these are going to be our valence electrons. Guys, anyone that is just joining in, welcome into the chat. My name is Dr. Andrew. Guys, make sure you comment down in the description box what topics you want to go over. And make sure you vote up in the poll. Do you want to go over A, Gen Chem, Organic Chemistry, Physics, or Calculus? Make sure you tap the top left button on your screen and vote A, B, C, or D. If you're new here, comment the word new so we know you're new. And if you've been here before, make sure you comment the lock emoji because we're locked in right now, chat. Guys, what's the next topic we should do here? Should we continue with this topic or should we move on to hybridization or unit conversion? Someone asked about hybridization. Let me see who that was real quick. Okay, and then Young Cook, let me know if this is helpful for you. Is this making more sense? Young Cook, let me know if this is making more sense. Okay. Grace says unit conversions, and then it's G said hybridization, guys. What's the next topic we should do? Is chemical engineering more chemistry or physics? I think chemical engineering is more physics. Even though chemical engineering has the word chem in it, it actually has a lot more physics than chem. Okay, any calculus? There's calculus and chemical engineering. I'm sorry if I missed what you meant by that. What are some good projects for chemistry combining with machine learning? That's a really good question. See, I'm not familiar with machine learning, so I couldn't answer that, unfortunately. All right, I'm seeing unit conversions and hybridization. AP Chem hybridization, Unit 2. What's AP Unit 2? What's AP Chem Unit 2, guys? Is that hybridization? I forgot what's AP Chem Unit 2, guys. Is that hybridization or what is that? 96 out of 99. Yo, W. Ionic equations. This makes sense, but IDK if that lone pairs are to just, or is just the dots like that. The lone pairs are the 2 dots, bro. the lone pairs or whatever is over here. So that's going to be our lone pairs right over here, twin. So each of these have two lone pairs. Each of these have two lone pairs here. So 1, 2, 3, 4, 1, 2, 3, 4. So the lone pairs are going like that. Okay. Hybridization resonance polarity here. So hybridization resonance polarity. Okay. That's crazy. Unit test. Unit 2, guys. What's unit 2? I'm seeing a lot of unit 2, so I'm guessing most people are on unit 2. Is that hybridization or is that? Let me see what unit 2 is. Let me see what unit 2 is real quick, guys. Okay, so if that's gonna be hybridization, then we'll do AP Chem unit 2. I forgot what that is. I know I made a video about it, but I literally forgot what's that topic here. Okay, compound structure and properties. This is basically unit 2. Okay, this is basically unit 2. Hybridization, we're basically going over unit 2. Yeah, so Lewis diagram. Okay, guys, let's talk about unit 2. Let's talk about unit 2. And let's talk about exactly what's going on here. Let's start to do bonds, guys. Okay, I think I have an idea. Guys, what we're going to do is we're going to talk about Lewis structures in unit 2 for AP Chem. But I want to talk about Lewis structures and then combining elements, Lewis structures and bond formations. Okay, if Lewis structures and bond formations is a good topic to do next, guys, make sure you put a thumbs up down below. If we want to do Lewis structures and bond formations, put a thumbs up down below. I'm also going to add molecular geometry as well. If this is a good topic to go over next, put a thumbs up down below. Okay, Lewis structures, bond formation, and molecular geometry. Let's see which ones are we can cover. Okay, thank you, Jeremiah. So I got one thumbs up here. Okay, so which of the elements are rare metals? Okay, thumbs up, good job, thank you. All right, thank you. So the metals are going to be over here. These ones are going to be the transition metals. Okay, and then the earth metals, these are called the rare earth metals. So over here we have the alkaline metals and the alkaline earth metals. These ones are called the rare metals. And then these ones are going to be the transition metals here. Okay, so let's talk about ionic versus covalent real quick, because I know that's a really important topic. So let's do ionic versus covalent. So I'm going to do ionic bonds. Okay, ionic bonds is basically going to be a metal plus a non-metal. Okay, a metal plus a non-metal. And what's a metal is anything that lives on the left-hand side. So let's go back to the periodic table. You're going to take your periodic table and make a staircase that looks like this. You're going to make a staircase that goes below each of these transition metals here. Okay, so go below here. These are the transition metals. Okay, so anything to the left of the staircase is considered a metal. So anything to the left of the staircase is considered a metal. So for example, nickel is considered a metal. Gallium is considered a metal. Calcium is technically a metal. Rubidium. So anything that is to the left is considered a metal. Anything to the right is considered a non-metal. So for example, neon is a non-metal. Chlorine is a non-metal. So ionic bonds are going to be metals plus non-metals, and they're going to are they going to share electrons or transfer electrons, guys? Are ionic bonds going to share electrons or transfer electrons? Comment down below. My pleasure, twin. Guys, comment down below. Are ionic bonds going to transfer electrons or share electrons? Okay, so my typical example for you for ionic bonds is going to be NaCl. Okay, transfer, good job. Okay, agent, too fast, good job. They're gonna transfer electrons. So for example, sodium lives on the right hand side. No, they're gonna transfer electrons. They're going to transfer electrons. Sodium lives on the left hand side rather. So if I have NaCl, guys, I'm gonna circle Na here. Na lives on the left hand side, and I'm gonna see it's in column 1. So how many valence electrons did we say sodium has? Well, if it's in column 1, we said that it's going to have 1 valence electron, right? And chlorine is going to live all the way on the right-hand side here. So chlorine is going to have 7 valence electrons here. So we're going to basically draw a bond here whereby the Na is going to lose an electron. And if Na loses an electron, it's going to gain a positive charge. And if Cl gains an electron, it's going to now have a total of 8 valence electrons. and now it's going to have a minus charge. Okay, does everyone understand how I got Na plus and Cl minus? If you understand how I got Na plus and Cl minus, go ahead and put a thumbs up down below just to make sure we're on the same page here. So I said that NaCl was a metal plus a non-metal. Na is a metal, Cl is a non-metal, so therefore it's an ionic bond. Ionic bonds are going to transfer bond, and then I said that's going to break apart into Na plus and Cl minus. So if you understand how I got NaCl is Na plus and Cl minus, comment down a thumbs up. Okay, Jaff, thank you. So I see one thumbs up here. Okay, if you got lost at any point, just put a crying emoji or a pot emoji so I know that we are cooked and I got to re-explain myself, guys. Do not be afraid to ask questions. Do not be afraid to ask questions. This is the perfect place to ask questions. All right, I'm not seeing too many questions about this one here, so I'm going to move on to covalent here. So I'm going to say that covalent bonds are going to be what kind of bonds here? What kind of bonds are covalent bonds, chat? Are we going to transfer electrons or share electrons for covalent bonds, guys? Okay, are we going to transfer electrons or share electrons? So let's write down what a covalent bond is. It's going to be a non-metal plus a metal. And what's a non-metal? It's anything that lives on the right-hand side, right? So non-metal plus a non-metal is anything that lives on the right-hand side. Good job. Okay, good job. Leslie, good to see you. Darlene said share. Good job. Leslie said share. XO said share. Jeff said share. And Val said share. Good job. So covalent bonds are all going to share electrons. And the first one that I want you to memorize, chat, is super important. It's because it's the one that we're made out of, this compound. So does anyone know what compound we're made out of? What compound are we made out of, guys? What compound makes up over 70% of our human body? This is Unit 2, Lewis structures, and we're talking about Lewis structures, bond formation, and molecular geometry. Okay, we do have a lot of carbon. Okay, good job. H2O, right? So H2O is going to be what we're made of. So I'm drinking some H2O right now. That's what we're made out of, guys. We're made out of H2O. So they're going to share some electrons. Here's how that's going to go down. First, we got to look on the periodic table. So let's get a nice fresh periodic table. And then I got to look for oxygen. So if you're confused about valence electrons, make sure you check my YouTube channel because I talk about valence electrons here. So H2O is given by H2O, just like that, right? All right, so we got to look on the periodic table, guys. The periodic table is your bestie for this class. If you do not have a periodic table, you're going to be cooked for chem because we need to see where the elements live. So oxygen lives right here, okay? And then H lives right here. Okay, so how many valence electrons is oxygen going to have, guys? How many valence electrons is oxygen going to have if it lives on the right-hand side of the periodic table? I'm not live every single day. I'm live Monday through Thursday. I'm live Monday through Thursday at 6 p.m. PST or 9 o'clock EST. Okay, Jeff, you're really close. It's going to be 6. Yes, very good. It's going to be 6, right? Okay, Eugene said stoichiometry. Twin, I just did stoichiometry yesterday. Make sure you check out my YouTube video because I did stoichiometry yesterday and I posted the live from yesterday, Twin. Good job, Jess. Good job, Ak. Okay, Ax said 6. Very good, guys. So we're going to say oxygen has 6 valence electrons. So we're going to build out the Lewis structure for H2O, which is what we're mostly composed of. All right, so we have 1, 2, and I said we go top down, side to side, just like that, right? So we have top down, side to side. All right, then I'm going to put another valence electron right over here and right over here. So that's a total of 6. Where did I get 6? Because I said that we go 8, 7, 6, right? So oxygen has 6. Hi, period. Okay. Do you cover Gen Chem 2? Absolutely. Okay, we're basically going over that soon. How much chem do I need to learn to get into nuclear enrichment? You do need quite a lot because you need to learn a lot about nuclear and radioactivity as well as physics as well. Does it matter where you draw the electrons? Kind of. Yes, it does. Okay, if you do this, it's gonna be wrong, guys. Do not do this. Do not do 1, 2, 3, 4. That's wrong, guys. Why is that wrong? Okay, do not do something like this. 1, 2, 3, 4. This is also wrong, guys. Why is this wrong here? We need to follow this structure here. Why is this wrong? If you guys did unit 3, you know why this is wrong, but in unit 3 you're going to go over exactly why. Okay, so just says, how do you know which element goes in the center? And make sure you check out my YouTube video because I cover over how to determine the center electron. So I mean the center atom. So the reason that we have oxygen in the center is because, well, H is only going to have one valence electron. It's going to bond just like that and just like that. Okay, now water is already our exception, and that's why chemistry is cooked, guys, because chemistry has a ton of exceptions. So this is also unfortunately wrong, guys. So what you're gonna do, this is gonna be your base Lewis structure. This is gonna be your step 1. But what I want you to realize is that in step 2, the valence electrons from the 2 oxygen pairs are gonna move up to the top just like that. Why? Because it does. And so we're going to basically create these little bubbles that you're going to learn about in Unit 3 called orbitals. Guys, if you've learned about orbitals, comment down a thumbs up emoji. If you learn about orbitals, comment down a thumbs up emoji. Okay, so these orbitals are kind of like bubbles, and they're kind of pushing our H down just like that. Okay, so this is our H molecule over here. This is H2O. Okay. Guys, so this is basically how we build out our H2O molecule. Leslie sees a thumbs up. Good job, good job. Cruz says thumbs up. Okay, cool, guys. So any questions about how I did H2O? This is our very first Lewis structure. Now, I do want you to learn something else. This is going to be in a later topic, but it's super important, and I want to tell you this right now. So if you're in AP Chem, you're not going to see this until Unit 4 or later, but if you're in College Chem, you need to know this. Okay, electrons, guys, what charge do electrons have? Everyone comment down below, what charge do electrons have? Are they positively charged or negatively charged? Okay, what charge do electrons have? Positive or negative? Everyone comment down below. All right, Agent says minus for negative. Jess, good job, negative. All right, M says negative. Good job, good job. Leslie, negative, very good. Okay, so I'm gonna put some little baby negative charges right over here to remind us that this side is negative here. Now, guys, did you learn about electronegativity in Gen Chem yet? If you learn about electronegativity, let me know. So electronegativity is basically the word that describes how much does oxygen like electrons. So let's see where oxygen lives on the periodic table. We see that it lives all the way to the right hand side over here. So anything that lives to the right hand side is going to be called highly electronegative. So highly electronegative means that it likes negativity. It's kind of toxic, guys. Oxygen is low-key toxic because it likes the toxicity, so it likes negative charges. Okay, so we're going to say that oxygen is very, very happy on this side, okay, to the point that it is so greedy that it is going to steal some electronegativity, from the protons. So on the top hand side, we're going to have some negative charges just like that. And on the bottom side, we're going to say that we have a little bit of positivity over here. So I'm going to represent this with the Greek letter called delta. So on the top side, I'm going to put partial charges to indicate that oxygen is highly electronegative. And then on the bottom side, we have basically poor little proton here that is partially positive. It's basically losing its electrons. And guys, we essentially created a magnet. And by magnet, I don't mean by a literal magnet in the sense that there's a North Pole and a South Pole. But what I do mean is we do have something where we have polarity here. Polarity here means we have a negative side up on top and a positive side down on the bottom. This is called polar. This is called polarity. So therefore, water is a polar compound here. Okay, let me know if I'm going a little bit too fast or if I need to re-explain something. But if this made sense, chat, let me see some thumbs up down below. If you're understanding why water is a polar compound, go ahead and put a thumbs up emoji down below. Okay, so Jeff said, how do sigma bonds and pi bonds work? That's gonna be a different topic. That's gonna be with bonds here. How do you know they are positive? They're not positive. It's because we have a partial positive charge. So the partial means that poor little h was so depleted by its electrons that it basically left a positive charge. Okay, I'm kind of mixing, guys. I started with unit 2. Yes, I started with unit 2, but I think this is also unit 5. I low-key, let me see, where is polarity for unit 2? Polarity unit AP Chem. I kind of was starting with unit 2, but I kind of jumped into a different unit as well. Maybe this is unit, Guys, let me know what unit is polarity here. I actually forgot. Okay, but I'm introducing this here in case you're in college or high school. So whether you're in high school or college, this should be helpful. Okay, polar, explain one more time. So guys, we're gonna do another molecule for polar. So let's do another molecule for polar so I can explain one more time. So if you have any compound with one element having high electronegativity, then it will be polar. Yes, we can do thermochemistry as well, okay? So guys, let's do another example for polarity, okay? Because I know this can be confusing, but I want you to know that water is polar. This is the most important compound of your entire life. Why? Because we're composed of 70% water. How much to memorize after Chem 1? Still a lot, right? Oh yeah, absolutely, there's a lot. In total, there's 3 bonds. No, twin, there's 2 bonds. So I see 1 bond right here and 1 bond right here. So guys, this one was H2O. Let's do another example. And again, if you missed this, I am recording this. I will post this on my YouTube channel. And I also have a video where I covered this as well. Let's do another example, guys. I'm going to give you this compound. I'm going to do CH3Cl here. Okay, I'm going to do CH3Cl. So guys, if you're taking AP Chem right now, I want you to get out your notes and practice following along. Okay, you're not going to learn through passive learning. You're not going to learn by watching and scrolling through TikTok. No, you have to actually do the problems on pen and paper. Okay, so get out your notes and try to draw this compound out here, CH3Cl here. Okay, so I have CH3Cl. All right, so we got to draw the Lewis structure and we're going to determine if this is polar or non-polar. All right, so which one's going to be the center atom, guys? Which one's going to be the center atom? Guys, let me do a quick little poll. Okay, if you think that the center atom is going to be carbon, you're going to comment carbon. If you think that the center atom is going to be Cl, comment chlorine or Cl for chlorine. Okay. Okay, so very good. So M said carbon. Okay, Sadie said Cl. Okay, guys, so how do we determine the center atom? So how do you know? Okay, how do you know? Jay said carbon, Agent says Cl, Pierre said C, Val said C. Okay. Guys, we're gonna figure out how to determine which compounds are more polar than other compounds. Guys, we're going over polarity next. So someone said carbon, but why? Good, I'm seeing a good mix. I think some carbon just as IDK. All right, guys. So I'm gonna guess. I'm just gonna guess that it's chlorine. Okay, I'm gonna guess that it's chlorine. So I'm gonna guess that chlorine is the center atom because I don't know. Like I've never done this compound before, so I'm gonna put chlorine right here. And then how many valence electrons is chlorine gonna have? How many valence electrons is chlorine going to have? How to determine valence electrons? From the periodic table, guys. Remember, the periodic table is your bestie. So periodic table is my bestie. I'm going to go to my bestie. I'm going to say, hey, bestie, how many valence electrons does chlorine have? And then I see that chlorine lives right over here. And then chlorine is right next to this one. So I'm going to say 7 here. Okay. Anything to the right is 8 here. All of these are 8. And then this one is 7. Good job here. Okay, so now guys, we're gonna put 7 valence electrons here on our bestie for chlorine. I'm gonna do 1, 2, 3, 4, 5, 6, 7 here. 1, 2, 3, 4, 5, 6, 7. Okay, good job. All right, so now we have 7 for chlorine. And let's see here. So we assume that this was our center atom. And let's see, we have a problem here. So I'm gonna put my, I'm gonna put my Cl over here. I'm going to put my H over here. If I put my H right over here, we have a problem. We ran out of electrons. So, okay, that's one like indicator that Cl is not our center atom. All right, but maybe I made a mistake here. Maybe I should put my H on the other side. Okay, so again, I ran out of electrons. So this is another indicator. So if you don't know, okay, because people ask me, how do you know which one's the center atom? Guys, I don't know. I'm going to guess. But what if I put my carbon over here this time? Okay, I'm going to put my carbon over here, and then now I see that carbon has, how many valence electrons does carbon have? Okay, how many valence electrons is carbon going to have? Again, I'm going to go to my bestie, and then bestie says, okay, I say, hey bestie, how many valence electrons does carbon have? I go 8, 7, 6, 5, 4. So carbon has 4 valence electrons, right? Good job, Jess. Good job, M. So carbon has 4. So I'm going to do 1, 2, 3, 4. Wait, this is actually making sense because now I'm going to erase this bond in a second. I'm going to turn this into a single bond, right? And then that's my CH3 here. So I have 3 H's left. And wait, take a look at that, guys. We're low-key cooking because I have 1, 2, 3 spots open for my H's to live right over here. Okay, So I have 1, 2, 3. So that's how I build my compound for CH3Cl here. Okay, let me bring this down. So, and then I have my extra electrons here, here, and here. And then I'm going to erase this and put a single bond, and a single bond. So I'm going to erase these bonds here and then turn these into single bonds just like that. Okay, so there we go. So at the end of the day, I guessed wrong, but even though I guessed wrong, I got the right answer because now C is my center atom here. Guys, does everyone understand why C is my center atom? If everyone's understanding why C is my center atom, comment a chemistry emoji. Okay, if you understand that C is our center atom, comment your favorite chem related emoji. And then we have our compound here, okay? I'm glad you're understanding. Okay. Thank you, Ethan. Put a beaker. Thank you, Ethan. Jaff put the same beaker here. Period put a, oh, that's a DNA symbol. Okay, guys. So now what we're going to do is determine if this is polar or non-polar, guys. So we got to determine if this is polar or non-polar. So, guys, we're going to do a quick poll. What do you think? Do we think that this is polar or non-polar? Okay, is this polar or non-polar? We're going to do we're gonna do a quick poll. Is this gonna be polar or non-polar? So let's do this poll here. So for CH3Cl, you're gonna vote. If it's polar, you're gonna say a happy face emoji, and if it's non-polar, you're gonna say a crying emoji, guys. Okay, so guys, here's gonna be a quick poll. You got 3 more seconds to think about it while I pull this up. All right, 60 seconds are on the clock. So if you think that CH3Cl is polar, you're gonna vote for a happy face emoji. If you think it's non-polar, you're gonna say it's a crying emoji. And comment why. You think that. Okay. Sandy says help. Sandy, what do you need help with, twin? Anthony says my brain hurts. I'm sorry, twin. Why does your brain hurt? Young Cook said, oh my God, what is going on? He looked away for 3 seconds and now we're over here. So we have to try and test what's in the center. Exactly, just try, okay? We're just gonna guess. We don't even know, we're just gonna guess. Sandy says, I don't get it. Okay, Sandy, don't even worry. I'm gonna explain it right now. So Leslie says, I think polar has to do with the metal and the non-metal, but I could be wrong. Good guess. Period is correct, net dipole towards the Cl, good job. So guys, period is actually, I wanna say, are you in med school or you're almost in med school? I forgot. So if anyone needs to go, if anyone has any questions about med school, you can drop them down below. Sandy says I failed my midterm. Oh no, because the uneven shape. Okay, good guys. So let's see the results. So you guys all said polar. So you guys cooked. So if you said polar, you're correct. So if you said polar, drop a thumbs up, drop a party emoji. Okay, drop some hands ups in the air. Okay, and if you were wrong, that's totally fine, guys. Let's go over why this is polar here. So remember, we have Cl here that lives on the right-hand side, and anything that lives on the right-hand side is highly electronegative here. So Cl is highly electronegative, and so what does highly electronegative mean? Highly electronegative. En is going to stand for electronegative. So electronegativity means they are greedy, guys. They are highly, highly greedy. So anything to the right-hand side is highly, highly greedy, except for our noble gases. Okay, so I like in the last live stream a couple weeks back, someone said that all the noble gases are represented by Kendrick. Okay, so the noble gases in column 18 is going to be Kendrick. And then anything that is left, for example, the halogens, that's going to be Drake. So Drake, he's pretty cool because he's so close. He's rich, but he's kind of famous, but he's no Kendrick. He's never going to be as cool as Kendrick. So he's desperate for clout, guys. Drake is going to do whatever he can to get clout, but he's so desperate. He's greedy. He's going to try to steal those electrons. He's never going to be like Kendrick, so he's greedy here. Okay, so anything to the right-hand side is highly, highly greedy. Now, what do we have here? Aha, we have a chlorine atom over here. So chlorine is on the right-hand side, guys. So chlorine is highly, highly electronegative. Carbon is your chill guy. Carbon is your chill guy here. He's going to be basically really, really chill. He doesn't care. He's not going to be greedy. He's going to be just like your chill guy here. Okay, so chlorine is going to absorb, it's going to suck up all the electrons from poor carbon here. The way we're going to represent that, guys, is going to be with an arrow. Okay, if you're in high school, don't worry about the arrow. If you're in college, lock in for the arrow. So if you're in high school, don't worry about this arrow. This is going to be called a dipole here, which points towards the more electronegative atom. Okay, if you're in high school, don't worry about the arrow. But for college, we need to draw this little plus to indicate that our poor little carbon is getting sucked up over here. And we're going to represent this with a partial negative here. Okay, so if you're in high school, don't worry about this delta symbol. Okay, if you're in high school, don't worry about these things here. So these are partial negatives. But if you're in college, you do need to know this. If you're in college, you do need to know this partial negative symbol here. And then poor carbon now has a partial positive. So therefore, we created a magnet. And by magnet, I don't mean literally a magnet. I mean we have a difference in charges. On the left-hand side here, we have a negative charge. And on the right-hand side, we have a positive charge. Therefore, CH3 is polar. Therefore, CH3 is polar. Guys, if that made sense, okay, if that made sense for polarity, drop a thumbs up, okay? If you understand why CH3 is polar, put a thumbs up down below. Oh, so Pranav says the dipole arrows are in high school level. So some of you guys do need to know the dipole arrows. If this made sense, drop a thumbs up. If this did not make sense, put a thumbs down. Andrew, what happens when you accept our study DMs? How do you utilize the website? You can always DM me for questions, twins. So you can DM me for questions or drop your questions up on the website. Guys, I'm gonna do a quick explanation on the website here, guys. Okay, the delta. So what's the delta, guys? That just means partial. That means it's a symbol that represents a little bit negative. It's not a full charge, it's a partially negative charge. My professor told us not to learn about that until Gen Chem 2. No way, twin, really. Liz, my goat. Can we do more of these? I just joined. Okay, guys. Okay, guys. So we're gonna do a quick poll. I'm gonna do a quick poll. Oh, I should have changed this here. So what's the next topic? Should we do more polarity? Same topic, polarity, or should we do a different topic? Different topic. Okay, guys. So think about that as I pull up the poll. Okay, so we got 60 seconds on the clock. If we want to do polarity, make sure you vote for a happy face. If you want to do a different topic, vote for a crying emoji, guys. Okay, and boom, 60 seconds are on the clock starting now. Guys, anyone that is just joining in to the chat, welcome in, guys. Super excited here. My name is Dr. Andrew Sanchez. I do want to show you guys about my website. It is called Engineering Minds. So if you have any questions about mathematics, chemistry, or physics, go to engineeringminds.co and drop your questions up on the website here. You can also book a free tutoring consultation call here, as well as join up the free Discord. Guys, the Discord is totally free, which you can join in and ask questions for mathematics, chemistry, physics, engineering. If you don't know whether you want to do biochem or chemical engineering, or you don't know if you want to do, mechanical engineering, electrical engineering, guys, there's a ton of people in there that are going to be super helpful for you as well. Guys, I go live every single week, Monday through Thursday at this time. So if you have any questions, drop them down in the chat below or up on the website, and explore the resource page here so you can see whatever topics you might have questions on for AP Chem, General Chem, Organic Chem, Math, Physics, and more. Thank you, Leslie. Shouts out Leslie, who's been a supporter for the last several months now, I think. Okay, and she just dropped a link down below. And I'm seeing a lot of requests to continue the same topic for polarity. So everyone said do more polarity. Okay, so everyone said do more polarity. So guys, we're going to do more polarity, and then after we're going to check what we'll do next. And guys, I think we're going to do Gen Chem for the entire night because I'm pretty much seeing only Gen Chem questions today. That's really interesting. Last week it was only OChem, and then this week it's only Gen Chem, and yesterday was only physics here. Okay, people say electrical is the hardest. Is that true? I do want to say electrical is really, really hard. Okay, I wouldn't know because I'm a chemical engineer, but I have heard the same thing. I have heard that electrical engineering is the hardest. Okay, all right, guys, we're gonna do another example. So last time we did CH3Cl. Now I'm gonna do another example here. Okay, I'm gonna do CF4 here. All right. So not only are we going to draw the Lewis structure, we're going to draw the Lewis structure and we're going to determine if it's polar or non-polar. Thank you, Sandy, for the 21 roses. I missed you, twin. Thank you for the 21 roses. And guys, thank you for 4K likes. And guys, let's keep it going. So everyone comment down below if you think this is polar or non-polar. But do be careful. This one is a small caveat here that we're going to discuss next. Okay, I'm going to explain the delta negative and positive. Don't worry, Jess. I'm going to explain the delta negative and positive. Yes, everything I'm recording right now will be posted on my YouTube channel, guys. So whatever I'm recording right now, I will post tomorrow, guys. So make sure you sub to my YouTube channel. All right, everyone's saying non-polar, non-polar. Darlene says polar. Guys, so let's go over the dipole one more time here. Okay, Natalie says dipole as well. Okay, cool. So guys, let's do carbon here. And which one's our center atom? We got to do, if this is the Lewis structure, which one's our center atom? Okay, apple, is that an apple juice box? What is that? Is that a bag? Apple bag? What is that? Tetrahedral. That is correct. So which one's the center atom, guys? I'm going to guess that carbon is my center atom. And then I'm going to just put my F's up on top here. Now, some of you are going to do it like this, okay? Some of you are going to do it like this. If you're in if you're in regular chem, I want to say this is fine, but if you're in AP Chem, do not do it like this. If you're in AP Chem or college chem, I don't want you to do it like this. If you're in regular chem, this is fine, but if you're in AP Chem or college chem, do not do this. Guys, why is this wrong for AP Chem and college chem? Why is this wrong for AP Chem? Okay, so what's the difference between the top one and the bottom one here? What's the difference between the top and the bottom here? So what's the difference between the top and the bottom here? Okay, so someone said there's a difference here. It says geometry. Good. Okay, the shape, exactly, right? Now we're talking about molecular geometry, guys. Okay, molecular geometry is going to be like, I think, a different unit for AP Chem. Let me see which unit real quick. Hold on, guys. I'll be right back. So we started with unit 2. But now we're kind of doing like unit 3. We're kind of mixing unit 2 and unit 3 a little bit now, guys. Okay, so the difference between the top and the bottom, they look the same, but now the shape is different. So this one is planar, this one's planar, but this top one is going to be a shape that we're going to call as a pyramid here. Okay, but it's not a pyramid. Let's draw it. It's going to be like this. So I'm going to draw this shape. Like this one's a box. So this box is not correct. Okay, this box is not correct. But this one has a shape. It's going to look like this pyramid shape, CF4. Okay, guys, does anyone know the name of this pyramid here? What's the name of this pyramid? Okay, so this pyramid shape is basically our shape for a CF4 compound. So what is the name of this? Yes, we're doing Lewis diagrams and sp3 versus sp2 as well as polarity here. So this one is wrong. So the name of this pyramid shape is called tetrahedral. Okay, tetrahedral, guys. So this is super, super important if you're in AP Chem or college chem. Okay, so the reason we have this shape is because this is going to be called sp3 hybridized. So this is going to be called sp3 hybridized. So super, super important that you understand this now. Okay, and then how do you know it's sp3? Guys, it's kind of like a memorizing thing. It's kind of like a, how do you know? Guys, I just know. So I'm going to erase this. I don't want you to draw it that way. Okay, and guys, it's going to be a little bit confusing at first, but over time, it's going to start to make sense. So I'm going to redraw that one more time and then draw these angles. So, okay, at first, the first time you do chem, it's going to feel weird. It's going to feel confusing and awkward, but over time, you're just going to just know. Okay, because a lot of people ask me, like, how do you know? And I say, well, I just kind of just know. Guys, it's going to take practice. Practice makes perfect, right? You're not going to get it right away. You need to practice every single day. Okay, great. So now I have my F's here. Now, is this polar or non-polar? So some people said polar, some people said non-polar. Now we have to determine the polarity. So we're going to do that process one more time. So I'm going to go to my bestie periodic table and I'm going to say, hey bestie, where does fluorine live? And then my periodic table is going to say fluorine lives right over here. Okay, so I'm going to circle my fluorine atom over here. Guys, is fluorine highly electronegative or not highly electronegative? If you think fluorine is highly electronegative, comment highly electronegative. If you think it is not electronegative, comment not. How do you know where to put it, that shape? How do you know where to put it? Okay, let me clarify that. How do you know where to make it? How will you know to make it that shape? Okay, highly. Everyone says highly. Let me review the shape real quick. Let me review the shape. If we have four single bonds, no electrons, no electron pairs, then it's going to be tetrahedral. Okay, so if we have 4 single bonds and no electron pairs, it's going to be tetrahedral. Okay, so that's how we make the shape. Guys, don't worry, we're going to do tons of examples here. Don't even worry, we're going to do tons of examples. Very good. So everyone says highly electronegative for fluorine here, right? Highly electronegative. Bear says highly electronegative. Okay, good job, good job. So now fluorine is highly electronegative, and that means that fluorine is super greedy, right? So fluorine is super greedy, and so we're going to draw an arrow pointing from the carbon to the fluorine atom here, and then we're going to draw that arrow with a line right here to indicate that poor little carbon is getting sucked up of all its juice. But meanwhile, wait, what's going on here, guys? Meanwhile, this fluorine atom is also pulling poor little carbon and getting sucked up with all its juice here. And then what do we have here? This fluorine is also pulling poor little carbon, is getting cooked up over here. Okay, this carbon is getting sucked up of all its electron juice. Okay, and then this fluorine as well. So now we have 4 different arrows that are drawing electrons from the carbon here. And then here's the part where I'm going to do the partial charges here, guys. Here's the part where I'm going to do the partial charges. So if fluorine is electronegative, it essentially acted like a magnet. It sucked up all those electrons from the carbon, and I'm going to represent that by the following Greek symbol. Let me clarify this slowly this time. So this Greek symbol, I'm going to use a delta, is the Greek symbol delta, that it is partially negative here. So this is a partial negative charge. Think of the partial negative charge as just a representation that it is like a magnet, and I don't mean a physical magnet, I mean a magnet in the sense that it sucked up all the electrons from poor little carbon. Okay, and so if we have a magnet over here that is sucking up all these electrons, we are going to have partial charges. But here's the question. Now, there is no dipole here, guys. Is there a dipole? Is there polarity here? Let's do a quick check. Let's do a quick check. Is this compound polar or non-polar? So is this going to be polar or non-polar? And then maybe I just gave it away, so you guys might already know because I accidentally gave it away, but let's see who's paying attention. So if you think it's going to be polar, you're going to vote for a happy face. If you're going to say it's non-polar, you're going to vote for a crying emoji. So based on all that, let's see who's understanding this so far. Okay, 60 seconds on the clock, starting right about now. So guys, if you think that this is polar, you're going to vote for a happy face emoji. If you think that this is non-polar, you're going to vote for a crying emoji. Okay, voting up on the top left of the screen. Okay, good job, guys. We have a competition here. The 5 delta, that was arbitrary. I just chose randomly 5. So don't worry so much about the delta, twin. Don't worry so much about the delta. Just ignore the delta. Okay, just ignore the delta. Imagine that I never put any delta here. Okay, because I think the delta is confusing you. Just imagine that I just have negatives over here. Okay, the delta is just a reminder. It's just a mathematical reminder for us to remember that these are partial charges here. So just remember that we have partial negatives. Okay, we have polyatomic from Taylor. Natalie says crying. Okay, guys, so let's see in the clock. Oh, guys, we have equal votes. Oh, guys, this one's tricky. We have almost equal votes. We got 5 for happy face. So we have 5 people that said polar, and we said 6 that said non-polar, guys. If you said non-polar, please explain why. If you said non-polar, please explain why. Okay, if you said polar, why do you think it's polar, guys? Wait, because can we draw an overall saying bottom is more negative than the top? Okay, so for polarity, we need to have a difference in charges. We need to have a difference in charges. So yes, there is a partial positive on the poor little carbon. However, this is called what I like to call the tug of war effect. This is like what I like to call the tug of war effect. So last time we saw that the fluorine was drawing electrons from the carbon, but because of the tug of war effect, we have equal and opposite directions pulling it in equal and opposite directions. So therefore, there's some cancellation of charges. There's some cancellation of polarity. Cancellation occurs. And so overall, we're going to have a net zero dipole. Net zero dipole. Okay? If this is making sense for the why this is non-polar, please comment down a thumbs up emoji. If you understand why this is non-polar, please comment a thumbs up. If you did not understand why this is non-polar and I need to re-explain something, please comment your question down below. So they're both on the right is why I think they are non-polar. The dipoles have to cancel each other out and only 2 cancel each other out. In PChem, do we use linear algebra? Yes, you do. Can you please go over MO? I got you, twin. So tetrahedral, therefore symmetrical, meaning nonpolar. So everyone's saying thumbs up, thumbs up. Jay said thumbs down. So Jay said thumbs down. So I was afraid that this one was going to be a little bit too hard. So let's do a quick analogy, guys. Let's do a quick analogy here. So let's do a physics analogy real quick. And then I have a box. So if I'm pulling the box, and then I have 2 people pulling the box to the right. So this person is pulling the box, and this person is pulling the box. Then I have a net force to the right here. So I'm going to draw an arrow. This is a net, F net. This is kind of like saying this is polar. This is kind of like saying this is polar because I have F net going to the right here. Okay? But if I have a box that is equally pulled on both sides, let's say I have a person here on the left-hand side. Okay? And then I have 2 people on the right-hand side. And then I have 2 people here on the left. Now, is there going to be a polarity here? If there's 2 equal and opposite forces and everything's equal, they have the same amount of mass, they have the same amount of force, is there going to be any net movement? Is F net going to be to the left, to the right, or 0? Is there going to be any net motion? Okay, is there going to be any net motion if I have 2 equal forces, one going to the right and one going to the left? Okay. Exactly, right? So exactly, right? So just said 0. No, 0, right? So there's no net force. There's no net motion here. So the net motion is canceling out here. Similarly, if I have a CO2 molecule, okay, yes, oxygen is electronegative. So yes, it is hungry for electrons. I'm going to draw an arrow going to the left. And yes, this oxygen on the right is also electronegative here. So there is electronegativity. However, this is non-polar. This is non-polar. Perfect timing. Do you go over circular motion? Absolutely. Okay, so back to this one here. So that was an analogy, twin. This is not doing physics right now. We can go over physics if you want. But this is an analogy. So here I have oxygen pulling equally to the right and to the left. But in this compound, it's in 3D space. So I have some going up, I have some going to the side, and I have some going down and some going to the side. So overall, this is a net no dipole here. Okay? How do you do the arrows again? The arrows are going to indicate which one is more electronegative, twin. So oxygen is highly electronegative. So the arrows indicate which direction is the electronegativity, guys. And if at any point you miss any of this and this is confusing, guys, don't worry. I will be posting this on my YouTube channel tomorrow, okay? So can you explain the Lewis structure? Twin, this is the Lewis structure for CO2. This is the Lewis structure here, okay? So we're kind of going over that here, okay? Is this the case for all tetrahedrals? No, this is not the case for all tetrahedrals. Okay, good question here. So let's go back to our other one here. CH3Cl. I didn't ask it before. I didn't mention it, but this one that we did earlier was actually tetrahedral. So we did say polar. So no, not all tetrahedral are nonpolar. Some tetrahedral can be polar. Some tetrahedral can be nonpolar. Okay. I do have videos on physics, Priscilla. You can check them out on my TikTok page. I have a physics playlist. Okay, I'm not sure if I have circular motion though. Okay, guys, I want to do another quick poll. I want to see how we're doing. Do we want to do the same topic or a different topic here? Do we want to stick to polarity and this kind of stuff, or do we want to do a different topic and move on altogether? Okay, guys, so I'm going to pull up the poll, and as usual, got 60 seconds on the clock. How's everyone doing this semester? Are you still cooking this semester, or are you starting to feel cooked? Okay, is everyone still cooking, or are you feeling cooked with midterms, with exams? Guys, how's everyone doing? Okay, 60 seconds on the clock. So, oh, I forgot to pull that up, guys. I forgot to pull that up, guys. My bad, my bad. Let me stop this. Hold on, let me stop. Okay, and then let me pull this up. There we go. All right, restart the poll. All right. So someone said cooked. Someone said cooked. Okay, guys. So basically, if you're feeling cooked, don't even worry, twin, because we have the Discord for you to join in and ask questions. We have those live streams, so you can review the practice problems and ask questions. And we have the TikTok Q&A on the link in bio, so you can ask your questions and you don't have to feel cooked anymore. Okay. People are saying different topic, different topic. I agree, guys. What's the next topic here? And then, guys, I need to pull up the example here. I need to pull up the next example here. So, Justin starting to feel cooked. Oh no, twin. Prissa says getting cooked. Alex says low-key cooking. Ooh, W. So I see a healthy mix of both, guys. I see a healthy mix of both. Natalie says doing mass percent right now. Guys, do we want to do stoichiometry? Guys, do we want to do stoichiometry? Alex says MO diagrams, or do we want to do MO diagrams? What's the topic here? So we're going to do a different topic. I just need to know what topic we should do. So I'm seeing some for mass percent dilutions. Lewis diagrams. Twin, we just finished going over Lewis dot structures. Jimena, we just finished, oh no, yeah, Jimena, we just finished doing, no, who was that? What did I miss? Who was that? So Taylor said, can you do Lewis diagrams? So this topic was, we just finished Lewis diagrams, twin. So I'm going to post this on my YouTube channel tomorrow. Okay. Jimena really wants to do mass percent and dilution conversions. Ooh, guys, we haven't done dilutions in a while. Okay, Jimena says, I see two for, okay, so someone said Jimena same and balancing equations. Guys, we did stoichiometry yesterday, so I posted it on my YouTube channel yesterday. So maybe we'll do dilutions today, because I posted the yesterday was stoichiometry, guys. So if you go to my YouTube channel, you can watch the stoichiometry. We can always review it again if you want, but I think we got to do something else because we did stoic yesterday, guys. Okay, Alex says MO and says NO. Yeah, ratio and canceling units. So let's do a quick poll. Let's do a quick poll. So if we're gonna do stoichiometry, let's do another poll. So stoic, and then I see like dilutions and molarity. Let's do another poll real quick, guys. One more poll and then we'll jump into it. One more poll and then we'll jump into it, guys. One more poll. Dilutions, molarity. And then, guys, my live stream schedule is going to be up on my stories. I go live every single week, Monday through Thursday. So if I don't get to your topic, don't even worry. Okay, I will be back again tomorrow. So you can join up on the Discord if I miss your topic. Okay, the Discord is totally free. Link in bio, guys. 60 seconds on the clock. Do we want to do dilutions and molarity or stoichiometry? So if you missed the stoichiometry, you can just watch that from yesterday. So, whoops. There we go. And very good, guys. So let's see who's cooking up right now. So we got equal votes. Guys, we got equal votes. We got 3 versus 3. So just it says you have to recognize the pattern. How to do Avogadro's number and count all that. Okay, guys. Which emoji for physics? Period. I asked the physics question earlier, and no one voted for physics. Oh, guys, I'm seeing a lot for stoichiometry. Okay? I'm seeing a lot for stoichiometry, guys. I'm seeing actually a lot for stoichiometry. That might actually win. Oh, wow. Stoichiometry actually cooked. Okay, guys. Stoichiometry actually cooked. Okay, 5 seconds left. 5 seconds left. Wow, it's really close. Okay, so here's what we're going to do, guys. Here's what we're going to do. So I started the live stream about an hour ago. Okay, I started the live stream about an hour ago. And I asked what topic should we do today? And Gen Chem was cooking, So guess what? We start with Gen Chem for the first hour, and Gen Chem was cooking today. So what we're gonna do is basically we're gonna do another hour of Gen Chem. So Gen Chem actually won, and we're gonna do 20 to 30 minutes of stoichiometry, and then we're gonna do another 15 minutes of molarity. So if you're ready to lock in for stoichiometry, comment a thumbs up. If you think stoichiometry is a good topic and you're ready to lock in, comment a thumbs up and a lock emoji. Okay, comment lock emoji and thumbs up emoji, because we're gonna lock in for stoichiometry. And then after stoichiometry, we're gonna do molarity in about 20 to 30 minutes. And if we still have time, then we'll do Q&A at the end. But again, don't worry. If you have a question that you did not get answered, do not even worry, because we go live every single week, Monday through Thursday at 5 o'clock PST. So if you have questions, you can join up on the Discord for free, guys. Just go to engineeringminds.co. So whether you're getting stuck for mathematics, chemistry, or physics, I got you covered. You can sign up for a free consultation call for tutoring at engineeringminds.co. And guys, I have all these resources here that I'm going to build out for math, chemistry, physics, okay, computer science, engineering, and biology. Super excited to be here out with everyone. So whether you're in high school or college, guys, I'm super excited to do what it is that I do. Guys, believe it or not, I actually struggled so much with STEM in high school and college. I got a C in college chemistry, and now I'm out here doing college chem and OChem. I struggled so much with organic chemistry as well, and I still got my PhD. So if you think that you're not ready for engineering or STEM, guys, do not even worry. I thought I was never gonna be able to do this stuff, and here I am out here giving advice to y'all. So if you think that you're not capable, do not give up, twin. Never back down, never what, guys. Okay, Jess says lock emoji, and a wolf. Prissa says lock. Yes, this will be posted. I'm gonna post this tomorrow. Leslie said lock. Alex, if you have a midterm, make sure you join the Discord, twin, so I can answer you right after the live stream. Juice says I don't understand what it meant. Of course, I got you guys, I got you, period. Never give up, exactly, guys, never give up. Thank you, guys. Thank you, exactly, guys. So make sure we're really, really motivational and supportive of each other. So if you join the Discord, I promise that everyone's really, really nice and supportive. So I make sure to mod it very carefully. So everyone's got to be really, really supportive, guys. All right, guys. So we're going to lock in for stoichiometry for about 20 to 30 more minutes. And then we're going to lock in for about molarity for about 20 to 30 more minutes. And then we're going to end it for today. But again, don't worry. This will be posted on my YouTube channel. And we're going to be back again tomorrow. And the next week after that. And the next week after that. So here's my general tips for stoichiometry. It's basically a recipe. So I'm going to go over everything that I went over yesterday. We're going to make a different recipe this time. So yesterday we made cookies. Today we need a new recipe, guys. So someone give me 2 reactants and their values. So I need 2 things that are going to make a product. But do not give me cookies, because yesterday we did cookies. So I need 2 things that are going to form together to make a product here. Okay, and if you're taking Gen Chem right now or AP Chem, I highly, highly recommend that you get out your notes. You're not going to learn through passive scrolling and viewing. You're only going to learn through active recall. That means I want you to actually follow along, do the calculations with me, and get out your calculators and your periodic tables. Okay, so, but I want like a fake recipe, Jimena. Okay, thank you, Jimena said HCN, but I want something like an actual food or like a product. So what's like a food or like a product that I can make? For example, like yesterday we said cookies. So today, what kind of food are we going to make? Is it going to be Krabby Patties? Is it going to be, I don't know, something to make a product here? Okay. Oh, snap. Period is cooking. Wait, that's a good one. Hold on. Period is cooking. Bro, chicharrones and plátanos for mofongo. Bro, that's actually cooking, guys. Can we do that today? Can we do that? Let's do that. That's actually cooking. Chicharrones, bro. Wait, that's wow. Wait, that's actually real good. Okay, next time we can do tacos. But today we're gonna do this one here. Chicharrones plus plátanos. All right, how many of each are we gonna make? What is the recipe? What is going to be our recipe? How many doses of each are we going to make? We are cooking up today, guys. We are cooking up today. So I'm going to use C for chicharrones, and then I'm going to use P for plátanos here, right? And then I'm going to use M for mofongo. So what are our numbers that we're going to put here, guys? How many of each are we going to put? Okay, so how many do we need? What numbers am I going to put here? Just put any random numbers here. Okay, so Rogelio said 1. So I'm gonna put a 1 right here. Okay, I'm gonna put a 1. Guys, I'm making this up here. I'm making up this recipe on the spot. Blank said 178. That's a little bit high. That's a little bit high. So I'm gonna put this as a 3. Okay, I'm gonna put this as a 3. And then maybe let's make 1 mofongo and then 2 plátanos here. Okay, guys, this is our recipe. So anytime you see a chemical reaction, just think of our recipe. So our recipe says we need 3 chicharrones and 2 plátanos. These are sausages, guys. If anyone doesn't know what this is sausages and then bananas. And then someone explain what is mofongo, guys. Someone explain down in the chat what is mofongo. Okay, so I think this is a good recipe for now, guys. If you think this is a good recipe, put like your favorite yum emoji. If you think that we're ready to cook up here, we have 3 chicharrones and 2 plátanos for 1 mofongo, right? Okay, and let's say we go to the store. Let's say we go to the store and then we buy, okay? Let's say we buy, 25 chicharrones, right? We buy 25C. Okay, and then we also buy, let's say we buy 30 plátanos. So we buy 25 chicharrones and 30 plátanos, and we're gonna calculate how much of the dish of the product we can make, right? Okay, oh yeah, pork skins. I said sausages, but it's pork skins, technically, right? Okay, cool. So now we gotta calculate how much product. So notice that on the left-hand side, this is what I have. My first tip for you guys, is always start with what you have. So this is how to make chemistry low-key easy. Always start with what you have. Step 1, always start with what you have. This is what I teach all my clients. And I wish someone would have taught me this way. Always start with what you have. If you start with what you have, it's going to make it so much easier, guys. Start with what you have. So start with what you have. And then, okay, so what do we have? We have 25C. So I'm going to write down, I have 25C. And then end with what you want. So I'm going to put equals. I'm going to put what I want on the right-hand side. So what do I want, guys? What do I put for what do I want here? What do I want on the right-hand side? Well, I'm hungry, right? So I want mofongo, right? I want mofongo. I want M, right? So I'm going to put M for mofongo. So I'm going to put M. That's what I want on the right-hand side, guys, right? My professor didn't think of dilution, but with a twist, use M1, V1. Okay, we're going to do dilution in about 20 minutes, twin. We're going to do dilution right after stoichiometry. The food reference is so good. Just use it to memorize. Exactly, right? Exactly. Good job, Jess. So we're putting mofongo on the right-hand side. All right, so what do I put right here? This is the confusing part for everyone here. So what am I going to put right here, guys, so I can get my units? This is the confusing part for everyone. And I can't even explain how confused I was. I remember going to my teacher. I was crying. I was bawling my eyes out because I was so stressed. Okay, but it's really this simple here. I'm going to put down here, I'm going to put the moles of what I have. And then I'm going to put the moles of product here. Because why? Because I'm going to cancel out. I'm going to put C. Okay, I'm going to put C right here so I can cancel out my C right here. Okay, and then I'm going to put my M up on top because I want my M up on top here, right? No, Jess, we're not going to use Avogadro's number. That's going to be for molecules. So everyone thinks that we're doing Avogadro's number. No, we're not worried about Avogadro's number right now. Okay, so exactly, we're going to put moles. But how many moles? So how many moles here? This is basically our moles. So how many moles of C do I have for every mole of M? Well, If I don't know, I'm going to go to my recipe. My recipe tells me, right? Exactly. Good job. Good job. I'm going to put 3 moles of C down here. And then I'm going to I'm going to produce 1 mole of product. So the 3 comes from this 3 over here. And then I'm going to produce 1 mole of product here. Okay, so I'm going to do 25 divided by 3. So I'm going to do 25 divided by 3, and I'm going to calculate that out. Okay, so I'm going to do 25 divided by 3, and then I'm going to get 8.33. I'm going to get 8.33, and that's going to be my moles produced of mofongo from the 25 chicharrones that I bought, right? Guys, if this is making sense how I got my moles of product here, drop a thumbs up. If you understand how I got my 8.33 here and you're still understanding, put a thumbs up. That's right, LPP, welcome in. You're just joining on the cooking. We're cooking up today, guys. All right, so got some thumbs up. Perfect. All right. So is it to find moles? The big M, guys, I'm sorry to confuse you. The M, we're not using M for molarity. Today, we're canceling chemistry. We're saying M is for mofongo, guys. We're saying M is not for molarity. We're saying M is for mofongo. Okay, I apologize for the confusion. But yes, normally big M is for molarity. Okay, but today we're saying M is for mofongo. So now we have 8.3 M of our mofongo. Okay, but we got to repeat the process because we used up our chicharrones, but now we have to check how many plátanos, how many bananas are we gonna produce here. I mean, consume to make our product. So again, if you're confused, always start with what you have. What's step 1? Always start with what you have. So what do we have? How many bananas do we have, guys? How many bananas did we start with? Remember, I said we went to the store and we bought 30 plátanos. We bought 30 bananas. So I'm going to say we have 30 bananas here. I'm going to say 30p. Okay, plátanos is bananas. All right, so I have 30p. This is what I have. Now, what does my recipe call for? What do I put in my blue box here? This is the hardest part for everyone, myself included. But what do I put in my blue box here? What do I put in my blue box this time? Okay, so good job, Leslie. Leslie said 2, and then we put 2 right over here. So we're gonna put a 2 on the bottom here. So this is what we have. So always start with what you have, and then the blue box is our recipe. So I'm gonna put 2 moles here in P, 2 moles P, and then now what about mofongo? We still only have 1 product here, so 1 mole M. Okay, so I'm gonna do 30 times 1 is 30 divided by 2, so I'm gonna do 15. Okay, so I produced 15 from my plátanos, and then 25 from my let's see, I did 15 from my plátanos and 8 from my chicharrones. So now I'm going to ask you guys which one is limiting. Which one is the limiting reagent? So think about which one is limiting. I'm going to do a 60-second poll. So you have about 20 seconds to think about which one is limiting versus excess. So I'm going to say C for chicharrones. Hopefully I spelled that right, guys. Hopefully I spelled that right. And then P for plátanos. So guys, you have 10 more seconds to think about that. All right, guys. And again, if you're taking AP Chem, I highly encourage you get out your notes and actually study along. You're not going to understand chemistry just by blindly consuming TikToks. I want you to actually pay attention and do the calculations with me here. Okay, I promise it's going to make a lot more sense. Here we go. 60 seconds on the clock. So we did our calculations here. We said we produced 8 mofongos here, 8.33 mofongos from 25 chicharrones, and we also said that we produced 15 mofongos here from 13 plátanos. Okay, so if you think that C chicharrones is limiting, vote for a happy face emoji, and if you think that P is limiting, you're gonna vote for a crying emoji. Good job, everyone. Everyone is cooking. Okay, everyone is cooking up today. We got 5, 6, 7 votes for chicharrones. Guys, if you voted for C, if you voted for happy face, comment down below. Why did you vote for happy face? 9 votes for happy face. Why did you vote for that? Why did you vote for that? Okay. So you only have 8 mofongos for 25. Exactly, right? Exactly. Jess, is that making sense? Leslie, which element will run out faster or something like that? Exactly. Which one is going to run out faster? Which one are we going to consume? That's what limiting means, right? Limiting is like what we're going to run out when we're doing our recipe. Okay, does everyone understand? You guys cooked that up. So I see 11 votes for this one is the limiting here. So let me know if that made sense. If that made sense, drop a thumbs up. Okay, this one is, so now our C, so because 8, okay, so 8 is less than 15, okay, then therefore C is limiting. So C is limiting, okay, and then we produced 8.33. So we're going to ignore this 15 now because that was false because we thought that it was true, but now we said that is now in excess. Now the last question is, guys, which one is, how much of excess is remaining? How do we calculate how much of excess is remaining? So how do we calculate how much excess is remaining? So now that we know which one's limiting, we know we're going to run out of limiting. So now how do we get the remaining excess here? Okay, we have to basically go backwards now. We basically have to go backwards, okay? Because now we have that our C is limiting. Now we're going to basically go backwards. So I'm going to start with 8.33. That was our produced. So now we're going to go backwards. Now I'm going to start with what I had produced, 8.33 mofongo. And now I need to go backwards. So I need to put something over here, and then I need to get my reagent here that I use to get excess. So which one's excess now? So we said that C was limiting. So let me write this down. So C is limiting. So which one's going to be excess, Chad? Okay, I'm going to put this one, P is now excess, right? Exactly. Now we're going to subtract here. Okay, so now we're going to subtract. Now we got to calculate how much was consumed. So now let's calculate how much was consumed. So I'm going to put my 1 here for mofongo. And then now I go back to my recipe, okay? And I'm going to say that 2P was in excess. 2P was in excess. Okay, so I'm going to do 8.33 times 2, which is going to be about 16.66. Okay, so now this is going to be 16.66P was consumed, but now how much is remaining? So how do I get, if I have that 6.66P is consumed, how much is remaining? Remember, all we have to do is see what we started with. So what did we start with? We started with 30P. So I'm going to take 30 minus 16.66. So someone please calculate, what is 30 minus 16.66? So someone please calculate, someone give me the value of 30 minus 16.66. And that's going to be our final answer here for the amount of plátanos remaining. And you know what? That's fine by me. We basically made 8.33 mofongo dishes, and we're still going to have a bunch of plátanos left over. So tomorrow we can have that for extra. Guys, we can have breakfast tomorrow. Okay? Exactly. So 13.44. Oh my gosh, guys, that's so much. So not only we are cooking up today, we are cooking up. Not only are we going to make 8.33 mofongo dishes, that's a lot already. On top of it, we're also going to have 13.44 bananas here, plátanos left over. And that is our final answer. Guys, all of the stoichiometry problems are exactly this way. I know it looks confusing the first time you do it, but I promise you every single one is like this. Always do step 1, start with what you have. And if you missed any part of this, don't worry, I will be posting this up on my YouTube channel tomorrow. Okay, so Sky says, can you do multi-step? Absolutely. So let's take it up a notch. Let's take it up a notch. This is not math, Cherry. This is chem. So we're doing math, but this is actually high school chem. Okay, I thought we just calculated. Wait, is that what we just calculated though? We calculated the 16.66. So I did 30 minus 16.66 is 13.44. Guys, is this making sense? If this actually helped you understand, go ahead and drop another thumbs up down in the chat, or drop a yum emoji because we were cooking, or a pot emoji because we were making our mofongo dish. Okay. And guys, so was this helpful? Let me know. Sandy, thank you for the roses again. Leslie, thank you for the heart me. Thank you for the love. We're about to hit 5K likes today. We're basically just about to hit 5K likes. And 2 gifts. Okay, Priscilla says thumbs up with some with the chef. Okay, good. So the last thing we calculated was the remaining excess. Exactly, right? Let me emphasize that here we have 13.44p remaining of excess. Exactly. So that was the last thing that we calculated here. Okay? So guys, we're going to take it up a notch. That was our primer, okay, for using our analogy. Okay? When you make chem fun, then suddenly it's not as scary anymore. When you make chem low-key fun, it's suddenly not as scary and you can understand all the topics a lot better. So, guys, if we're ready for the next example, let me know. If we're ready for the next example, comment down comment the word ready. Okay, thank you, Leslie. Got a thumbs up. Chef, a um a physics thing. Okay, a guy in STEM and a woman in STEM, and then a chem emoji. I love that. I love that you keep doing. I like super inclusive, guys. Super inclusive. Okay. Okay, so like shouts out all like the women in STEM guys. Like if anyone is, thinking again, if anyone's thinking like, oh, I'm not ready for this, oh, I'm not good enough, guys, trust me, I was feeling the same way. Have you heard about imposter syndrome? I had imposter syndrome. I did not believe that I was ready for this. Jess says ready, Princess says ready. This is the same math used for dosage calculations. That's right. For dosage, you also need this math as well. For dosages, that's going to be stoichiometry as well. Okay, absolutely, Chase. Anyone can be an engineer if they try hard enough. All you have to do is just lock in for like a year for your math, chemistry, and physics, and anyone can do that. Hello, Fred. Guys, we're gonna do a harder example here. So now we're gonna do a harder example, and guys, we're about to log in here. So this time, if you weren't using your notes before, I really want you to get out your notes this time here. And then let's see. I want to do, guys. Should we do a college level example or an AP Chem level example? Let me know. If we should do, let me do a quick poll. I want to see. Now I'm really curious. Should we do show which example next for stoichiometry? Stoic. Should we do high school AP Chem or college here? Okay, yesterday we did college level, but I think that one was too hard. But let's just see just in case here. Okay, which example next for Stoic? Okay, so guys, make sure you vote in the poll here, guys. Bringing that up one more time. Bringing that up here. So if we want to do a college example next, you're going to vote for a, let's see, if you want to do a high school example, vote for a happy face emoji. If you want to do a college example, vote for crying emoji. Oh, interesting. I'm seeing a lot of crying. Oh, Bree says easy college. Okay, easy college. Got it. Easy college. So I think yesterday I went too hard. I went for like hard college. So today I'm gonna try easy college. Yeah, that's fair. I like that. That's fair. If you want to see the hard college one, just check out the YouTube video. Okay, I like that. That's a good example, guys. So let me just look for one that's hopefully not too bad. And then in about 5 or 10 more minutes, or about 10-15 minutes, we're going to switch gears here to molarity here. We're going to do molarity. And I think I want to do something like this. Okay. I want to do something like this. Okay, so everyone said college. Okay, interesting. So I'm going to try to find one that's not too hard, but not too easy either. But unfortunately, these ones are kind of hard. So I think we're going to just log in anyway and do these anyway. Okay, so this one's looking pretty good. All right, so we're going to do another recipe here. Okay, we're going to do another recipe. But instead of food, like we were doing a second ago, instead of doing actual food, we're going to do an actual compound here. Okay, so here's our next example. And we're going to lock in for this recipe is going to be CH4, okay, plus O2 gas. And then that's going to produce, okay, CO2 plus H2O. Okay, what's the problem here? Twin? Okay, before we can even start this example, what do we got to do? Here? What time zone are you in, Twin? I'm in the PST time zone, so it is not even 7:30 for me yet. Okay. ionization energy, and the next compound, electron affinity. Young Cook, electron affinity is another word for electronegativity. So actually, we were talking about electron affinity a little bit. Unbalanced, all right? Bree says balance the equation. Good job. So we got to balance the equation, okay? We got to balance the equation here, guys. So we got to basically say, so how many carbons are we going to need on the left and the right? So I see that we have 4 H's here and 2 over here. So I'm going to multiply this by 2. And then let me make this bigger so you guys can see that. So I'm going to multiply this by 2. And then on the left-hand side, I see we have carbon, and then so that's pretty much good there. But I do see that we have 2 oxygens here and 2 here, but I only have 2 here. So I'm going to multiply by another 2 right here. Okay, so now we're ready to go, and I got to tell you how much we got here. Okay, I got to tell you how much we got. So we got to go to the store. Okay, we got to go to the store. And then instead of going to the food store to get our recipe, to get our ingredients for our dish, we got to go to the chem store. Okay, so I went to the chemistry department, and then I bought. So what I have is, let's say I have, 100 grams of CH4. I have 100 CH4 grams, 100 grams of CH4, and I have 82 grams of O2, right? And what I want to know how much water I produced. How much water I produced. Okay? So here's our practice question. It's going to say, all right, 100 grams of CH4 was mixed with 82 grams of oxygen. How much water in grams was produced during this reaction? Okay, so what's going to be our game plan for this example, chat? This one's going to be a little bit harder than the Mofongo one because now we got to do some conversion factors. So who knows the first step for this problem? Who knows the very first thing we got to do here? Okay, this is not quite photosynthesis, twin, because this is methane, so this is methane combustion. So this is called combustion because we're producing CO2 and H2O. Okay, so good guess though, because it's similar to photosynthesis, but actually no. Okay. All right, so Prissa says multiply grams times the molar mass. Very good. So we're gonna multiply grams to the by the molar mass to get moles. So step 1, okay, start with what I have. Step 1, always start with what you have. Always start with what I have. So what do I have? So what do I have this time? Okay, so always start with what I have. So if I have, what do I have here? What do I have? Oh, Zombie says, how do we balance faster? I always lose time during exam because I take a little too long on each step. Oh, Zombie, don't hate me, but the main answer is going to be practice. Okay, bro, practice every single day, and that's how you're going to get faster. There's no secret. There's no magic formula to balancing faster. It's going to be practice here. Okay, just as IDK, so just twin. So I said I went to the store. I have 100 grams of CH4 and I have 82 grams of O2. So I'm going to write down what I have. So what do I have, twin? I have 100 grams of CH4. Okay, and so I'm going to put always what I have is always what I start with. And then what do I want? I'm going to put what I want here. So what do I want? Okay, I'm going to start with what I have and I'm going to end with what I want. So what do I want? Exactly, good job. So you said we have CH4 and O2. There you go. Okay, no problem, no problem. So what do I want this time? What do I want? Okay, so I have my 100 grams of CH4 and then I want my grams of O2, H2O, right? I want my grams of H2O. Good job. Okay, good job, good job. So I'm going to put grams of H2O on the right-hand side. Now, some people get really confused because they want to jump from here to here. Okay, they want to jump from here to here. So they're good on the first step, and then they get confused from this step to this step. So we're going to do it all step by step. Okay, and guys, make sure you get out your notes and your calculator. I don't want you to just blindly watch this on your phone, on your bed. No, you're not going to learn that way. You have to actually follow along and actually follow along with your pen and paper. So if you actually want to learn, make sure you're not on your bed right now. Get out your notes and follow along. Okay? Guys, so I'm going to start with my grams of CH4. So first things first, I'm going to put my grams of CH4. I want to convert grams to moles. So how do I convert grams to moles? Okay, I'm going to convert grams to moles here. I'm going to divide by something here. So how do I convert grams of CH4 into moles of CH4? Okay, so how many grams per mole of CH4? So let me calculate the molecular weight of CH4. So how do I get that, guys? Again, if I'm confused and I don't know where to go, who do I ask? If I'm confused and I don't know where to go for chem, who am I going to ask, guys? Okay, I said bestie is the periodic table is your bestie here. So if I'm lost and I don't know where to go, I'm going to go to my bestie. I'm going to say, hey bestie, where's CH4? And then bestie is going to reply and say, oh look, we have C right here is 12.001, 12.011. I'm going to round it. You're not going to round it on your exam. I'm going to round it for demonstration's sake. I'm going to say 12. Okay, but on your exam, you're not going to round it. Okay, if you're taking the MCAT, you're going to round it as well. But if you're in high school and college, do not round it. And then I have 4 right here. Okay, I have 4 H's. So 4 times 1 is 4. So 12 plus 4 is 16. So that's how I got 16 grams per mole. Guys, does everyone understand how I got 16 grams per mole? Let me know. Yes, Jess, you need the periodic table, okay? Bestie is your periodic table for Gen Chem twin. You really, really need the periodic table. Otherwise, you're going to get really, really confused. Okay, good job, Bree. So Bree said 12.011 and then 1.008. Okay, good job, guys. So everyone's saying more exact answers. I'm going to leave it as the rounded answers, but you guys are going to do it more exact. You guys are going to need the actual numbers. I'm going to round it here for demonstration purposes. Now, I'm going to divide this number here by 16 here. I'm going to divide by 16 grams per mole. Why did I divide here? Why did I divide and not multiply? Okay, who knows why I divided by 16 grams and not multiply? Okay, I have 16, again, I have 16 grams of, I have 100 grams of CH4 and then I have 16 grams per mole. The reason I divided here was because I can cancel out my grams and now I have moles of what? I have moles of CH4. Okay, now I have moles of CH4. Okay, now I have moles of CH4 here. Okay, to get moles, okay? So we can just cut it out. Exactly, right? Good job to cancel out grams. Good job. Everyone's cooking today. I'm so proud. Everyone's cooking up today. I'm so proud. Now, I have moles of CH4, but what do I want? I want grams of H2O. Before I do grams of H2O, I'm going to make your life easier. Let's not worry about grams yet. Let's get moles of H2O. Let's make our lives a little bit easier. And let's get moles of H2O first. And then we're going to get grams. Okay, so now I have moles of CH4. How do I convert moles to moles now? So I did a grams to moles conversion. How do I get moles to moles? So right now I'm over here. And how do I jump from here to over here? I go back to my recipe. So if you were here for our mofongo dish problem, we went back here. Let's go back to our mofongo dish real quick. So for a mofongo dish explanation, we said we started with our example, our chicharrones and plátanos here, right? And then we said that we had 3 moles of C for every 1 moles of product. So that means I'm going to divide by my stoichiometric coefficient. This number 3 is going to tell me what I'm dividing by, and I'm going to multiply by that value here. Okay, Jess, that's a really, really common misconception. We're not using Avogadro's number this time, twin, because Avogadro's number is going to be for molecules. Okay, that's a really, really common misconception. We do not need Avogadro's number for this example. I'm really proud of you for saying that. I'm really proud of you for saying Avogadro's number, but we do not need Avogadro's number here because we do not need molecules. Avogadro's number is for molecules. Avogadro's number is for molecules. We do not need, okay, Avogadro's number. Okay, I was just like you. I always thought we needed Avogadro's number for everything because they make such a big deal about it. Okay, just like how your teachers make a big deal about Avogadro's number, I'm going to make a big deal about moles. I want you to think of everything in terms of moles. We don't need to worry so much about Avogadro's number. I know they make a big deal about Avogadro's number, but I want you to think of everything in terms of moles here, okay? So I have 1 mole of CH4 here. I have 1 mole of CH4 that I'm going to multiply down here in the denominator. And then how many moles of H2O product? How many moles of H2O product are we going to produce here? Okay, yes, Avogadro's number is only for particles and molecules. So how many moles of H2O product? If I want moles of H2O, what number are we going to put up on top here? Okay, let me do a quick, okay, you guys got it. So Bree said 2, Krista said 2. Good job. Okay, does everyone understand why I put 2 moles of H2O up on top? Does everyone understand why I put 2 moles of H2O up on top here? Okay, now we're going to do this calculation here. Okay, so I'm going to do 100 times 2 divided by 16. So I'm going to do 100 times 2 divided by 16 here. Okay, Jess, don't worry, twin. I'm gonna rephrase that one more time. Remember, step 1 is start with what I have, and let's review what we did. First, we got grams, and then I said grams divided by grams gives us moles, and then notice I have moles of CH4, right? So I have moles of CH4 up on top, and then take a look here. I have 1 mole of CH4 over here, and I want H2O. So if I start with CH4, but I want H2O, I see that I want a 1. So this 1 is going to go down here. Okay, and this 2 comes from this 2 H2O over here. So I'm going to put a 2 over here. Okay, so this calculation was our recipe calculation. That's why we spent so long doing the mofongo example. So I want you to see that this is our recipe ratio here. Okay, so what we're gonna do, Angel, what's good? We're doing stoichiometry, bro. Is that my bro? Is that my bro Goals? Okay, is that Goals or is that another Angel? 100 times 2 divided by 16. 100 times 2 times 2 divided by 16, and it's gonna be 12.5. We're gonna do 12.5. Okay, 12.5 moles of H2O. Okay, 12.5 moles of H2O. So let me do a quick pause here. Let me see if everyone understood how I got 12.5. If you understand how I got 12.5 here, let's see some thumbs up, guys. If this made sense so far, how I got the 12.5, let's see some thumbs up down in the chat if you're good on this step here. Okay. Loud calculator, I'm sorry. So when you bounce it down in the beginning, it gave you 2 H2O, right? Okay, Bree, thumbs up. Bree's cooking today. Prissa's cooking, thumbs up. Okay, guys, so now we have our moles of H2O. And then what was our next step? Remember in the last example, we did our mofongo. We basically said how much of plátanos we ran out of, right? So what was the next thing we got to do? So we always start with what I have here. So what's the next thing I got to do here? Okay, what's the next thing I gotta do? So let's do a quick review. So last time I started with what I have. So remember, I started with 25C, and then I got my mofongo. And then I started with 30P, and then I again got my mofongo. And so I was identifying the limiting reagent here. Okay? Yeah, we're doing mainly stoic, and then we're gonna do molarity in about 5-10 minutes here. We're running out of time, though. We're running out of time. Okay? So I'm gonna do my next one here is 82 grams of oxygen here, guys. So I'm going to do 82 grams of oxygen, and I got to convert this one into moles. So how am I going to convert this into moles? Similarly, you're going to go onto your periodic table, bestie, and basically say that the molecular weight is a 2 times 16, and we're going to say that it's 32 grams per mole. I'm going to go quickly here, guys, because I want to get the final answer so we can switch topics to molarity here. So then I'm going to do grams divided by grams to cancel that out, and I have moles of O2, and great. Now, what's going to be my molar coefficients here? What are going to be my molar coefficients for moles of oxygen to moles of H2O? Remember, if you're confused, always start with what you have and always end with what you want. So I started with oxygen, and so what number goes in front of oxygen to convert into H2O? What number goes in front of oxygen here, and what number goes in front of H2O? I don't want to see this. I'm doing organic chem right now. Chase, I go live every single week, Monday to Thursday, bro, at 6 o'clock PST. Very good. So I see a 2 and a 2, a 2 and a 2, and a 2 and a 2. Good job. Good job. Everyone's cooking. So now you guys got it. I got to put a 2 down over here for moles of oxygen and a 2 for moles of H2O, right? So I'm just going to cancel out these moles, and then very good. So mathematically, I have an 82 times a 2 divided by 32 times a 2, which is basically these 2's are going to cancel out. So I'm going to do 82 divided by 32. So I'm going to do 82 divided by 32, and then 2.56. So I'm going to put a 2.56 for the moles of H2O produced here. Okay, guys, so now you already know what I'm going to ask you next. You already know I'm going to ask you, you already know what I'm going to ask you next. So if I produced 12.5 moles of H2O from CH4 versus the 2.56 moles of H2O, which one is limiting? Which one is limiting? So if I'm going to say CH4 is limiting, or I'm going to say that O2 is limiting, which one is it going to be? Okay, quick poll. You got 5 more seconds to think about it. Okay, good job. So 60 seconds on the clock. So if you think that oxygen was limiting, you're going to vote for crying emoji. And if you think that CH4 was limiting, you're going to vote for a happy face emoji, right? Maria, limiting means that it's going to run out, right? Limiting, it's going to basically get depleted during the reaction. We're going to run out, we're going to consume all of that reactant during the reaction here. Exactly, right? So it says which reactant runs out first, right? Okay, it says which reactant runs out first. Guys, and if at any point you missed this entire live stream, I will be posting the entire live stream tomorrow up on my YouTube channel. So you can rewatch the whole thing and review it at your own pace. Okay, guys, so 5 seconds left on the poll. So everyone's cooking again. So everyone said that O2 was limiting. If you said O2, same question for you. How do you know that O2 is limiting? How do you know that O2 is limiting? Comment down below. Okay, so everyone was cooking, and everyone said that O2 was limiting. So you guys are right. Good job. I'm so proud. I'm so proud. So O2 is limiting. Okay, O2 is limiting here. How do we know that O2 is limiting? Okay. So now, how much is produced? Okay, how much is produced? Okay, exactly. 2.56 is less than 12.5. Okay, 2.56 is less than 12.5. So the 2.56 is less than the 12.5 here, right? Exactly, right? So O2 is limiting. So that means how much was produced. So therefore, we have 2.56 moles of H2O produced, right? 2.56 moles of H2O is produced. And we're almost done, guys. We're almost done because they said how much water H2O was produced. But we don't want moles of water, we want grams of water. So we're almost home. What's the very last thing we got to do to convert 2.56 into grams? What's the very, very last thing we got to do? And then we're done with this problem here. Okay. What's the very, very last thing? Okay, and we already got most of the molecular weights. Okay, I need to get my molecular weight of water. So for homework, I want you guys to try this out. So for homework, how to get molecular weight of water is 18 grams per mole. So I'm gonna give you the molecular weight of water is 18 grams per mole. Try this for homework. Okay, and then I'm gonna basically multiply my 2.56 moles of H2O times my 18 grams per mole. And then at the end of the day, I'm going to get my grams of water and we are done. So I'm going to do 2.56 times 18. And I got 46.08. Okay, I got 46.08 grams of H2O. Technically, we need sig figs, so I'm going to do 46.1 grams of H2O. And we are done. Yay! Good job, everyone. Good job, good job, good job. Guys, if this made sense, let's see some... I don't even know what emojis to ask anymore. Thumbs up, party emojis, cheers, fires, cooking. If this made sense and you're feeling a little bit more confident about chem, drop a cheer emoji or a party emoji down below. And again, don't worry, I will be posting this on my YouTube channel if you need to review. You're not going to get it right away, okay? You're not going to get it in the very first take. It's going to take a little bit of review. It's going to take a little bit of lock in, okay? But I promise that if you review this and do it again by yourself, oh my gosh, it's going to make so much more sense, okay? Guys, I told you I struggled so much when I was taking Gen Chem and Organic Chem, and I still locked in and I still got my PhD. So again, anyone that thinks that I'm not ready for chemistry, I'm not ready for STEM or engineering, I want to be a doctor, but I don't know if I'm ready. Trust me, you are more than ready. You just have to do a little bit of lock in, okay? Angie, my pleasure. Okay, I hope this was helpful. Good job, good job. So, guys, we got 46.1 grams of H2O. That's the final answer here. Have an exam on this tomorrow. I wish I can post it tonight, but TikTok takes about 3 hours to process the video. So it's going to take a couple hours to just process and then another hour to upload. So as soon as it's done processing, I will post this, but usually it takes several hours. This is my favorite part of chem. I love this. Oh my gosh, that's so great. What college did you go to? I went to UC Riverside. Thank you. No, Jess. No, thank you so much, Twin, for your comments and encouragement. I really appreciate everyone's being really, really nice. Guys, I promised that the next topic was going to be dilutions. So I'm going to jump right into dilutions because I got to head out in about 5-10 minutes. So I'm going to jump right into dilutions. If you missed this, just watch my YouTube channel tomorrow. All the link is in the, everything is in the link in the description. Guys, I'm going to do one more topic here. We're going to do dilutions and molarity. And we got to end it here. So I'm going to go really, really quick for dilutions. Okay, so dilutions is basically, this is the next formula. Remember, we had molecular weight is grams per mole, we had Avogadro's number, and now we need one more formula here. Is going to be molarity for concentration. Molarity is what? Molarity is what, guys? What's going to be the formula for molarity? What's the formula for molarity, guys? Moles over liters. Moles of solute over liters of solution. So everything that you did in stoichiometry, guess what? You're going to have to do it again. So if you're not comfortable with stoichiometry, you're going to be struggling a little bit with molarity. So don't even worry. We're going to do a bunch of examples, okay? So for example, I have 40 grams of NaOH. Okay, I have 40 grams of NaOH in 500 milliliters. I want molarity. Oh no, how are we gonna do this, guys? How are we gonna do this? So if you've never seen molarity before, I know this is gonna look scary and confusing, but trust me, as soon as you do the step-by-step process, it's gonna make a lot more sense, okay? I promise it's gonna make a lot more sense. So step one, guys, what is step one? Anyone that's been here for the last hour or two, what have I said at least 5 times by now? What is step one always gonna be? What is step one always going to be? Okay, the reason I wanted to pursue chem until Orgo. Oh no. I usually go live Monday through Thursday at 6 p.m. PST or 9 o'clock EST. Exactly. Good job, Leslie. Good job, Prissa. Start with what you have. Exactly. Good job. You guys are cooking. Always start with what you have. Always start with what you have. So what do I have? I'm so glad, guys, you guys are making my day. I'm so glad people are actually paying attention. You guys are actually learning. This is making my day. I've always wanted to be a teacher / tutor, so this is my dream job right here, guys. So I have 40. What do I have this time? Okay, so what do I have? So the problem is I have 2 things. So which one am I going to start with? Okay, and then I'm going to start with what I have, and then I'm going to end with what I want. So I'm going to start with 40 grams of NaOH. So I got to convert grams into what? How do I convert grams? What do I got to convert grams into? Start with what you have, exactly. Convert grams into moles. Okay, very good. So convert grams into moles. Good job, guys. Good job. So how many moles of NaOH? So we're running out of time. So for homework, I want you to try it out. And I do have a TikTok on this exact problem on my TikTok page. So just swipe right to my TikTok and click the #chemistry playlist. Okay, if you want to see the solution. But I'm going to get that the molecular weight of NaOH is 40 grams per mole. Okay, I'm going to get 40 grams per mole. So I'm going to divide by my 40 grams per mole. Okay, and then I'm going to get 1 mole of NaOH. Cool, guys. So now I have moles of solute. Guys, this is your equation. Molarity is moles of solute over liters of solution, right? So I have molarity equals moles of solute divided by liters of solution. So NaOH is my solute here. So I have moles here. So I'm going to put a check mark right here because that is what I have. I have my moles of NaOH. Now I got to get my liters of solution here. So I don't have liters. I have milliliters. Okay, so how do I convert 500 ml into L? How do I convert 500 milliliters into milliliters? Okay, remember from unit 1, we got to do our unit conversions. Guys, chemistry is the study of unit conversions. Okay, chemical engineering is literally just unit conversions with extra steps. How would I know? Because I have a PhD in chemical engineering, and literally all we do is unit conversions. It's crazy. It's actually insane. Okay, so I'm going to say that 1000 ml here, 1000 is down here, ml on the bottom is up on top here, liters here, right? And so now I'm going to say 500 divided by 1000, that's going to give me 0.5 liters. Okay, beautiful. So now I have moles of solute. Remember I said I have 1 mole of NaOH divided by 0.5 liters. Okay, and then I'm going to divide that. Okay, so I'm going to say 1 mole. So my equation for molarity is given by M. Guys, if you see M, it's going to stand for molarity. Okay, I know that earlier we said that M was mofungal, but now we're going to say M stands for molarity. So M is molarity, that's moles of solute. So how many moles of solute do we have? We said we have 1 mole of NaOH. And then how many liters of solution do we have? Okay, we're going to have 0.5 liters of solution. Okay, and then we're done. So 1 divided by 0.5, guys, that's going to be 0.2 molar. So we're going to say molarity equals 0.2 molar. Okay, and we're done. Okay, and we're done here. So that's going to be our example for dilutions. I take it back. Some people think that dilutions is harder than stoichiometry. Some people think that dilutions is easier than stoichiometry. Let me know what you guys think down in the chat. If you've already taken Gen Chem, let me know if you think that concentration, molarity, and dilutions is easier than stoichiometry, or you think it's harder than stoichiometry. Okay. That's right. Chemical engineering is not the same as chemistry. Yeah, that's right. Okay. Even though chemical engineering has the word chemistry in it, it actually is not the same as chem. Ooh, thank you for the pumpkin. Thank you for the pumpkin. Okay. 1 divided by 0.5 is 2. Okay. Did you get 1 mole by putting 40 over 40? That's correct. Okay. I want you guys to try that part for homework. I skipped this part for homework. I skipped this part because I want you to actually try it out. So let me know how I got the 40 over here. So I did 40 grams of NaOH divided by 40 grams per mole. So that one, I want you to try it out for homework, okay? I think they're both hard. Jess, I agree. I'm like Jess, guys. Believe me, I was like Jess. I thought stoichiometry was hard. I thought dilutions was hard, okay? Don't you have to figure out the mole for NaOH and times it by that? Times it by that. Wait, am I missing something? What do you mean? What do you mean? Guys, it is 7:50 my time. I'm going to be on for about 10 more minutes. I'm going to do basically a last minute Q&A. Whatever last minute questions you guys have, let me know. We basically did a lot today. So we started with Gen Chem review. We started with the periodic table. We did stoichiometry and dilutions. And if you missed any part of this live stream, don't even worry because I'm going to post this up on my YouTube channel. Let me just bring up my YouTube channel so you guys can sub to that right after this. Okay, it's the same as my TikTok. Just look up dr.andrew.sanchez. Doctor, final answer should be 2. Oh my gosh, guys, what did I do? I put 0.2. Guys, wait, I'm getting messed up right here. My apologies. I put a 0.2. It should be a 2. There we go. Sorry about that. Guys, let's make sure everyone got that. Okay, my bad. Now that explains why someone said, am I missing something? Because I messed that up, guys. I put a 0.2 on accident, and then there should be a 2 molar, okay? 1 divided by 0.5 is a 2, not a 0.2. Okay, is molarity the same as concentration? Yes, molarity is another word for concentration. Do you have any context on gas laws and formulas? Okay, Caitlin, I'm going to give you a real quick context for gas laws. There's one equation that you need to lock in, and honestly, gas laws is not, in my opinion, it's not as bad as stoichiometry. Okay, it's usually not as bad as stoichiometry. For gas laws, you're going to need the ideal gas law here. So the ideal gas law says that P times V equals nRT. Okay, P is going to stand for pressure, V is going to stand for volume, N is going to stand for moles, R is the constant, and T is the temperature. So they're going to give you 2 of these. So if I give you pressure and volume, I need to get temperature. If I give you temperature and volume, how do I get pressure? So they're always going to give you at least 2, and then you're going to have to get the third one using the calculation. Okay, molarity is for aqueous solutions, correct? Okay, molarity is for aqueous solutions. It's not for liquids per se, it's for aqueous. Aqueous means that it's in a solution of water with a volume. Okay, so you can think of it as like liquids. Yeah. Any tips for Chem 2, especially entropy? Guys, for chemistry 2, when you get into thermodynamics, I want you to realize the conservation of energy. Okay, conservation of energy is basically my famous equation. When in doubt, in equals out. Okay, it's not my equation, it's just like what I like to call the chemical engineering equation. The chemical engineering equation. When in doubt, in equals out. Okay, so that basically says we cannot produce mass out of thin air. We cannot produce energy out of thin air. That is called the first law of thermodynamics. So if you understand that, it's going to make it a lot easier for Chem 2. Do you have anything on YouTube for activity series on metals like redox or oxidation? Not yet, Anna, not yet. But I definitely got to get on that. So is that a um is that urgent for you? When's your test on oxidation reduction? Says I have a test on that Thursday. Exactly. You need Q equals MCAT. Can you do a review of motion graphs? Sarah, I'd love to, but I'm gonna be out of here in the next 5 minutes. So I'm only taking any last minute questions today, and I gotta end it here, twin. But I will be back tomorrow, okay? So we can definitely do physics tomorrow. This is good and all, but how will any of this help me get? Okay, this can help you if you basically lock in and get a job. If you get a job in STEM, you can make a lot of money. Of course, Alina. Okay. All right, no worries, no worries. Guys, like I said, I will be posting the entire live stream on it tomorrow. Bye, Jess. Bye, Twin. Thank you. Rest, make sure you lock in, buddy. I know you're in the Discord, so make sure you lock in and then drop in your questions. Girls like unemployed guys. Okay, guys, let me just bring up my website here so you already know, guys, I love the design here. I'm just going to be like flexing this for the rest of the night here. Okay, if you go to engineeringminds.co, that's going to be where you can download all the resources and all the links for everything here that you can find for STEM. I'm going to tune in tomorrow. This is cool. Of course, Chase, appreciate you. The Discord is going to be the free community that I can join. So if you want to join the Discord, that's going to be the perfect place for you to drop in and ask your questions for STEM, meet other members, and ask questions about STEM and engineering. Just go to engineeringminds.co and click the link that says join Discord. Okay, what did you mainly focus on for your PhD research? My PhD research was on photochemical nitrate reduction, which means that I studied UV photocatalysis in the presence of nitrate contaminated groundwater, and I basically studied the transformation byproducts of the nitrogen species. Translation, I used UV lights to turn bad water into good water. Good night, good night. Can you do a problem with variables like the chem ones that you asked to find substance X? So Noah, we just locked in for that exact topic, so make sure you check out the recap tomorrow, bro. I'm gonna post it on my YouTube channel tomorrow morning as soon as I did that. What job did you get with your PhD? I'm actually self-employed. So I finished my PhD 1 year ago, and I've been self-employed for 1 year doing private tutoring because I love teaching. Guys, pretty much going to end it soon. I'm going to be on for about 5 more minutes. Just going to be dropping my Discord here, all the link in bio. Guys, if you need to sign up for tutoring, I got you for all the various STEM subjects, whether it's mathematics, chemistry, physics. You can sign up for a free consultation call at the link in bio at engineeringminds.co. So basically you get a lot of hugs, bro. I never said that. I never said I'd get any. I never said that, okay? Of course, my pleasure. My pleasure. Thank you, Leslie. No, you. No, you. All right, guys. Pretty much going to end it, but I will be back tomorrow around the same time. Live stream schedule will be up on my story. This video will be posted tomorrow for the recap. The Discord is free. And pretty much going to end it here, guys. Not gonna lie, it must be difficult to keep client relationships professional. Actually, it was that hasn't been a problem so far because I try to keep it professional, guys. Even though I'm on TikTok, I try to keep it professional, guys. I mostly do STEM content. Okay, I try to keep it real. So I tell you guys all the real stuff, but I try to keep it professional always. bro, chill, body, chill. Thank you, Leslie. Thank you. Thank you, Leslie. Thank you, buddy. You're. I feel flattered. I feel flattered, bro. I keep it professional. Don't even worry. I keep it professional, guys. Okay, guys, I'm pretty much gonna end it. I will see you tomorrow in about 22 hours. Super appreciate you. Thank you so much. Really appreciate y'all's interaction, your support. Really appreciate you guys commenting and answering the questions and dropping in on the Discord and the chat. So I will see you guys tomorrow. So peace out. Have a great rest of your night and stay safe.